How's it going, ladies and gentlemen? Mr. Donnie here once again with 20.8 corrosion objectives. We want to be able to explain what corrosion is, its significance in modern society, and ways to prevent it. All right, so what is corrosion? Corrosion is basically just undesired redox reactions. So examples would be like rusting of steel beams, rusting of car parts, etc. All this is unwanted redox reactions because we want that metal there for structural integrity and stuff. This not so inspiring. Like, oh, let me walk across that. Corrosion breaks things apart. We don't want that always. All right. So corrosion of iron, which is in steel. So that's pretty common building material. When it does occur, when does it occur? When there's oxygen and water present. So if you got oxygen and water, you're going to get corrosion. So what's going on there? Well, oxygen is being reduced and iron is being oxidized. So here we have the oxygen being reduced to give us some water, and we got iron being oxidized to give us iron +2 ion, which is water soluble, will dissolve away and be gone forever. And you don't want that with your structures, okay? So iron conducts electricity, so it can lose electrons in one area, have them travel through the metal, and be gained by oxygen in another area. So here is a visual. So we have iron becoming iron +2 ion. So that's occurring at the anode, right? So we have iron losing its electrons and becoming +2. So well, what's going to happen to that cation that just formed? Well, it's water soluble and it can dissolve away and it's no longer part of the structure. And you're going to see some pitting here. So there's going to be parts of the material missing where that's occurring. And the other half is oxygen being reduced in the presence of H plus and 4 electrons, giving us 2 water molecules. So that's occurring at the cathode because that's reduction. So I'm not drawing all these perfectly, okay, but this is what's happening. So the oxygen's gaining those electrons. What's going to happen is that iron ion is going to come over and react again with the oxygen losing 1 more electron, and we're going to get this complicated reaction going on here where we have 4 iron ions and oxygen reacting with water and some other water. Now the 2x here is basically, it's just saying that some of that water, this dot here, is saying that you're making a hydrate, and this water is physically trapped in the crystal that is formed from the iron oxide here. Okay, so that's all that's happening there. Yeah, so what's going to happen there is we're going to get a hydrate, an iron oxide hydrate that's going to be deposited where it's being reduced at the cathode. So you're going to get some of the rust color that you're familiar with. That's occurring where the water meets the oxygen right there. And then what's happening underneath the water is where it's being pitted and losing material. Okay, so how can you prevent corrosion? One way is to take a look at the pH. So we see this is half a reaction, right? This is the reduction of oxygen, requires H plus there. So what's that tell you? Well, it tells you that if you raise the pH, the H plus concentration will decrease. So basically, if you make sure that there isn't any H plus, then you won't get that reaction occurring. So how do you do that? You raise the pH, and this will inhibit the reaction. So generally speaking, pH greater than 9 and iron will not rust. So if you can change the pH that the iron is exposed to, that's one way to prevent corrosion. All right. So other ways is just pretty simple and straightforward, painting the surface. So that's why one of the reasons why our cars are painted. That's why bridges tend to get painted and are painted all the time, because if you coat it with paint, you're sealing in the metal so that the metal isn't exposed to the water or the oxygen and it won't corrode. That's one way to do it. Pretty simple, straightforward. Another way is to coat it with another metal. So they call this galvanizing. So you can get galvanized nails, which is basically just iron steel that's coated with a thin layer of zinc. So the way this works is the zinc is going to be more active than the iron. So iron reduction potential has negative 0.44 volts, and the zinc has a negative 0.76 volts. So if we're talking about which one's going to oxidize, well, oxidizing iron would give us 0.44 volts, and oxidizing zinc would give us 0.76 volts. So which one's more likely? The zinc. So the zinc wants to be oxidized more than the iron. So what's going to happen is if you coat iron with zinc, the zinc is going to be the one that gets oxidized and not the iron. So I got another image for it, another animation. So because zinc is more active, it will be oxidized instead. So we have this going on. Is it going to be oxidized at the iron, or is it the zinc? It's going to be the zinc, right? So this makes the iron the cathode. So what happens at the anode, the zinc, is that the zinc is going to oxidize and lose its electrons and become +2, and it can be the sacrificial anode, if you will. So over here is where you can get some of the pitting, and it's not going to be on the iron. All right, so what's going to happen at the iron is going to be that reduction where you're going to get the depositing of the oxides and stuff. So you're not losing any metal. You're not losing any metal. You're not losing any of the iron, the structural part. So this is known as cathodic protection. Cathodic protection, because you're making the metal you want to protect the cathode and the other one the anode. All right. So other examples of cathodic protection. Say you had some underground pipes connected to a more active metal. So the pipes, you're not going to want to have to dig those up and replace them just because they've corroded, and that's going to happen if you don't do anything and you just put them underground. They're in moist soil, and with they're going to rust. So you can connect it to a more active metal, in this case magnesium, which wants to oxidize more than the iron pipe, right? So if one of them is going to oxidize, it's going to be the magnesium. So the magnesium is going to be what loses the electrons, and the electrons are going to go over to where the pipe is for the reduction to occur. But what's happening is that the magnesium is going to be the thing that oxidizes and loses parts of itself. So the pipe becomes the cathode, and it won't oxidize. So you protected the pipe. The pipe not going to oxidize. But magnesium is what we call a sacrificial anode. So it's sacrificial because we're going to lose it. It's going to get corroded, but it's, what we want to corrode instead of the pipe. It's the anode because that's where oxidation occurs. So it's a sacrificial anode. It's something that we know is going to corrode, but we're okay with it because we're doing that on purpose. All right, so the magnesium, you can see, starts to corrode, and it's going to rust, and it's going to rust. Now, once all that magnesium has corroded, instead of digging up all of that pipe that's underground, we just got to dig up the sacrificial anode and replace it. So we just dig that up, remove it, and put a new one in. And then the pipe continues to be protected. We don't have to worry about digging up all of the pipe we buried. All right, so only the magnesium will need to get dug up and replaced. Awesome. Other uses, you'll see this a lot in ships. I don't know if you guys, if you're boating fans or enthusiasts or stuff, you might see these metal bars attached to ships at different points. It's the same idea. So we have this big metal ship, and we don't want the side of the ship to corrode. It's in water. It's going to be exposed to oxygen. It's likely to corrode. But hey, why don't we connect some sacrificial anodes? So all these white dots that you're seeing all over the ship, those are pieces of metal. I think they use magnesium, and they're going to be our sacrificial anodes. So you'll also see they usually will say something like "do not paint," because you don't want to protect that sacrificial anode. You want it to be the one to jump on the grenade and get corroded. All right, so I want to make a special shout out to Engineer Guy on YouTube. Look for the video Anodizing, or the Beauty of Corrosion. It's a great video about how corrosion can actually be used on purpose for things that we want to do, like give color to our iPods and stuff like that. It's really cool. Check it out. All right. But to summarize, there are a number of ways to address corrosion of metal structures. Tips, real world applications: keep your tools dry. You get something wet, dry it off. All right. You got your ice crampons, dry them off before you store them away. You got a hammer and it was raining out, make sure you dry it before you put it away. You don't want that stuff to rust. All right. So I hope you found that helpful, and I will see you in class. Okay, bye.